Hello everyone, welcome to Shiwam's classes. In today's lecture, we are going to discuss problem number 8, 9 and 10. In previous lectures, we have already discussed from problem number 1 to 7. So just like in any other lecture, we'll first try to discuss the concepts and then try to solve the problem. So the very first concept here is again that we need to remember that in which quadrant which trigonometric functions are positive. So we know that everything is positive in this quadrant. My sine and cosec are positive in this quadrant. My tan and cot are positive in my third quadrant, and my cos and sec are positive in my fourth quadrant. So this is the very first thing. The second thing is we need to know that any trigonometric function if multiplied by an odd multiple of pi by 2, odd multiple of pi by 2 plus or minus theta will change to sine, will change to cos, cos will change to sine, and then depending on in which quadrant this angle is going to lie, we'll have to come up with the sign. So I'm just going to write plus and minus of cos theta. So here if I have to write it in a better fashion, so I will write it is gonna be plus or minus of cos theta depending on which quadrant it is gonna lie. Same is the case with cos, odd multiple of pi by 2 plus of minus theta will become plus or minus of sine theta depending on the sign, and then we have to look at in which quadrant it is gonna lie, but cos will change to sine. Same thing, tan will change to cot, and cot will change to tan, sec will change to cosec, and cosec will change to sec. So this if odd multiple of pi by 2 is there. But if it is even multiple of pi by 2, then sine will remain sine, cos will remain cos, and all that. The third thing which we need to know is that need to remember again is that pi equals to 180 degree, and this implies pi by 2 equals to 90 degree, and so on and so forth. So yeah, now with this in mind, let's look at this problem again and look at this LHS. My LHS is cos of pi plus x into cos of minus x divided by sine of pi minus x into cos of pi by 2 plus x. So cos of pi plus x, when you look at cos of pi plus x, so pi is from here to here and then x is further here. So this is gonna be my pi, this is gonna be my x. Pi plus x is going to be in my third quadrant, and this is pi is an even multiple of pi by 2, so cos will remain cos. So this will become cos x, and since it's gonna be in the third quadrant, then this will become my minus. Now cos of minus theta, cos of minus theta or cos of minus x is this. We have to go in this direction. The angle is negative in this other direction, angle is positive in this direction, positive direction, negative direction. So cos of minus x, this is gonna be in fourth quadrant, and cos is positive in this quadrant, so cos of minus x is gonna be cos x. Now sine of pi minus x, look at sine of pi minus x. So pi is going to be from here to here, and if you look at a little bit of x, which is going in the other direction, so it's gonna be in the second quadrant. So sine of pi minus x will become sin x, because pi is my even multiple of pi by 2. So this becomes sin x. Now look at cos pi by 2 plus x. Cos pi by 2 plus x, where will cos pi by 2 plus x will lie? So this is going to be my pi by 2. This is going to be my x, right? So this is going to be in my second quadrant, and pi by 2 is in odd multiple of pi by 2. 1 into pi by 2, pi by 2 is 1 into pi by 2, which is an odd multiple. So cos will change to sine, so sine it will be, and then cos is actually negative in the second quadrant, so it will be minus of sin x. Alright, so this is what it is. Now look at this expression, this is minus and this is minus, this will become plus. This is cos square x divided by sin square x. There are two x's, so this is gonna be cot square x, which is nothing but RHS. Alright, now let's move on to the second problem and see what is being asked over here. So in this question, LHS is given as cos of 3 pi by 2 plus x into cos of 2 pi plus x into cot of 3 pi by 2 minus x plus cot of 2 pi plus x. Alright. Now, when you look at this problem, cos an odd multiple of pi by 2, so cos will change to sine, and 3 pi by 2 is gonna be 3 pi by 2 is where 1 pi by 2, 2 pi by 2, 3 pi by 2 plus x. So this is gonna be fourth quadrant. So cos will change to sine, and the sine of this will remain positive. So plus of sine x, we don't have to write. Now cos 2 pi plus x. 2 pi is what? 2 pi is 4 into pi by 2, which is an even multiple. So cos will remain as cos, and this 2 pi by x. So 1, this is 1 pi, this is 2 pi, and then this is x. Right? This is pi, this is 2 pi, this is x. So this is gonna be again in the first quadrant. So cos of 2 pi plus x is nothing but cos of x. Right? Now multiply and look at cot 3 pi by 2 minus x. Cot, and this 3 pi by 2 is odd multiple of pi by 2, so cot will change to tan. That is one thing which we have to write, tan of x, and 3 pi by 2 minus x. So again, just when you look at this 3 pi by 2 minus x, this is pi by 2, this is 2 pi by 2, this is 3 pi by 2, and then minus x. So this is what is gonna be my angle, and from here to here it is gonna be 3 pi by 2 minus x, and we have to look at, this is gonna be third quadrant where cot is gonna be positive. So yeah, this is gonna be positive. Now plus cot of 2 pi plus x. Again, as I did in the previous one, 2 pi is like going the full circle and then coming further up. So cot will remain as cot, because 2 pi, again as I said, it is even multiple of pi by 2. So cot will remain as cot of x, right? Now look at this. This is sin x into cos x, and this is tan x can be written as sin x by cos x, and cot x can be written as cos x by sin x. Alright. Why did we do it? Because we were saying this and we have to cancel it out, and on the right hand side we are just seeing something like 1. So we know that this will cancel out. So that is why we reduced tan x to sin x by cos x, and cot x to cos x by sin x. So now look at this, sin x into cos x, and this is gonna be my LCM, cos x into sin x. I can take cos x into sin x as LCM. Now cos x will cancel out, so this will become sin x into sin x, and the other one will become, this will become cos x into cos x. Now this sin x cos x will get cancelled out, and this will become sin square x plus cos square x, and we know that sin square x plus cos square is nothing but 1. So this is what we had to prove on the right hand side. So it is proved. Let's go on to the next problem. Alright, so this is my next problem and the last problem of the day. So this is my LHS. This is sine of n plus 1 into x into sine of n plus 2 into x plus cos of n plus 1 into x into cos of n plus 2 into x. Alright, this is what has been given to us. So now this is looking like this is repeating. N plus 1x is here, n plus 1x is here, n plus 2x is here, n plus 2x is here. So let's assume n plus 1 into x is nothing but a, and n plus 2 into x is nothing but b. So let's see what this LHS becomes. This will become sine of a into sine of b plus cos of k, which is nothing but cos of a minus b. So now let's put back the value. This is the formula of cos a minus b. So let's put back the value. Now n plus 1 into x minus n plus 2 into x. Let's open it up. Cos of nx plus x minus nx minus 2x, and x gets cancelled out, minus 2x plus x, so this is cos of minus x, and we know that cos of minus x is nothing but cos of x, so which is nothing but RHS. Yeah, this is what we had to prove. So now we are done with problem number 8, 9 and 10. If you have any questions, please ask me in the comment section below and I'll be happy to help you. Thank you so much for watching this video.